Hello everyone, welcome to our YouTube channel Statistical Hub. Today we are going to learn how to do one-way ANOVA test in SPSS. I am Pooja Chakravarti, a student of MSc 3rd semester, Department of Statistics, Assam University, Silchar. Now, without any further delay, let's get started. Let us first see what ANOVA test is and why we use it. ANOVA, which is also called Analysis of Variance, is developed by Sir R. Fisher. It is a statistical technique to study the significant difference between mean of more than two samples. In ANOVA, generally we use F statistics, which is given by F equals to variation between samples divided by variation within sample. Now, there are some assumptions which we have to keep in mind while studying ANOVA. These are the first one is population from which the samples are drawn should be normally distributed. The second one is samples are independent and random. And the third one is each one of the population has same variances. In ANOVA, there are generally two techniques. The first one is one-way ANOVA and the second one is two-way ANOVA. Today we are going to study how to do one-way ANOVA in SPSS. First of all, in one-way ANOVA, there is only one independent factor which influenced the different sample groups. In one-way ANOVA, there is only one source of variation in the samples. To test if there is a significant difference in the mean current salary of different categories of employees, let us first set our null hypothesis, which will be H0 such that the mean salary of the officer, director and the executive are equal. Against the alternative hypothesis, at least one of the mean salary of an employee is different. To do ANOVA in SPSS, let's open our SPSS. Because the data is too large, we will just import the data in SPSS. If you want to learn how to enter data in SPSS, then there is a detailed video about how to enter data in SPSS in our channel. You can learn it from there. To conduct one-way ANOVA, go to Analyze, then Select, then Compare Mean and then one-way ANOVA. Here we have to choose the variable which we want to test. Let's select salary of an employee and then move it to the dependent list box as we are considering it as our dependent variable, and then the designation of the employee and move it to the factor. Since we also want to see the descriptive statistics, that's why click option and then select descriptive and then continue and lastly OK. Here we can see our output. First is the descriptive table. Here we can see our categories, then the values of N and then mean, standard deviation, standard error and the other descriptive statistics. Now the ANOVA table. Here we can see our value of F is 27.502 corresponds to the significant value which is less than 0.001 and then obviously it is less than from 0.05. Now what we can interpret from this table is that we will reject our null hypothesis and accept our alternative hypothesis, which is at least one of the mean salary of this employee is different. Now in our descriptive table, here we can clearly see that the mean salary of an officer is 36.42000 and that of executive is 35.41667. There doesn't seem to be much difference between these two, but the salary of the director is 52.4583, which is far away from the salary of these two groups. Our result of ANOVA told us that this difference is big enough to be called statistically significant. Now keep one thing in mind, that when F will be significant, that is when we accept our alternative hypothesis, then we have to see that the mean of which group is significantly different from the mean of other groups. To see this, we will have to do this ANOVA test again with an additional command. For this, go to SPSS and then analyze and then compare mean and then choose one-way ANOVA as same as before. Here, as we can see, our dependent variable and the factor is already selected. Now, click on the post hoc option. A long list of tests appears. Each of these tests has its own interpretation. Select "to-get test" as it fulfill our today's purpose. Then continue and then lastly OK. Now here in the output window, the descriptive and the ANOVA table is same as before, but there is an additional table which is telling us the pairwise difference between officer, executive and director. As we can see, the difference between mean salary of officer and executive is not significant because its significance value is greater than 0.05, and that with director is significant because its significance value is less than 0.05. Similarly, the difference between mean salary of executive and officer is not significant, but with director is significant. Lastly, the difference between mean salary of director with both the officer and executive is significant because both of it has significance value less than 0.05. Hence, from this we can conclude that the mean salary of the director is significantly different from that of the other two groups, that is officer and executive. So this is the detailed analysis of one-way ANOVA in SPSS. Thank you for watching my video. I hope you will like it. If you like my video, then please like and share my video and also give us some feedback through comments. Lastly, please subscribe to our YouTube channel for more interesting videos. Thank you.